Several of us agents across North Dakota, extension agents and the extension specialists and so forth, were involved in a corn establishment trial this past summer, and we're going to give you an update on what actually happened in this part of the state. There were several counties that participated in this trial. Tim Becker, the county extension agent from Eddy County, New Rockford, will introduce us to what we did. Lindsay Maddock, the county extension agent in Wells County, stationed in Pheasant, will present some material as well, and I'll kind of wrap up what we tried to accomplish this past summer and give you some insight as to what we're seeing so far.
Well, again, last spring we had the opportunity to get involved with the corn establishment trial. Joel was saying the three of us, and I guess anytime there's an opportunity like this, we like to get out if we can. It's better than sitting in the office, and get out and actually learn a little bit. And with the increased acres of corn that we had coming into this region of the state, we thought it would be good, another reason it would be good to get involved. But I guess what we were looking at is the different factors that affect stand. Corn coming out of the ground, we all know that an even corn stand coming up, that we tend to get better yield. But a lot of this data has been done before. There's data on Minnesota, I believe Wisconsin, Ontario. But there's never really been anything like this done in North Dakota that I'm aware of, or at least if there has, it's been a while. So we got involved with this, and the goal was to take it to harvest. This is a statewide project. This is the first year. I believe it's going to be done for 2 years, so we'll be doing it again next year. And if I'm not mistaken, I think it was done in at least 11 counties in the state. The person that led into this is Lindsay Maddock, who is the county agent out in Stutzman County. I think she's working on her master's degree, and this is part of a research that she's doing for her master's degree. So that's kind of how it got started. But in the Tri-County area, we had 5 sites. I had 2 in Eddy County. One of them I was able to take to harvest, as you all know, I'll drive last spring. I took one trial into July, but the trial got so dry, the producer ended up chopping it, so I lost that one, being able to take it to harvest. So I ended up with getting production data off of one. In Foster County, there were 2 trials. In Wells County, there was 1. And Greg Andrews was kind of our team leader in the area here, and I think we would all agree that without Greg's help, it would have been a lot bigger challenge for us. Our objectives of this project were basically, again, like I was saying, the factors that affected yield at the end. But so what we were doing is going out on this trial after we got started and collecting information on late emergers, doubles, skips, and plant spacing, and finding out what the years did within those. How did that affect the yield at the end? We looked at to quantify losses associated with these problems and identify practices and procedures, equipment that might be correlated to these problems. Again, our goal was to, I guess, provide farmers with data on the relative importance of uniform stand and better understanding what factors predispose these fields to obtaining the best yield that they can get out there. Our initial data that we collected from the producers that we were involved with was, so this was before we went out to the field, it was a legal description of the field, soil type. We looked at tractor wheel type, whether it be a tractor or a tire, planter model, air pressure on the tires, amount of field residue, moisture conditions at planting, how wet it was, hybrid that was planted, what type of land prep was used, whether it was conventional or no-till or minimum till, the planting date and the planting rate, and previous crop and seeding depth. So we looked at a lot of different information we got out of it. I guess I'll turn it over to Lindsay. But that set up the before we got started, and Lindsay will go over, I guess, the stops or the different times we went out there.
We basically narrowed it down to about 4 different visits. Our first visit consisted, well, I should start, it was at emergence, or around 120 degree growing days. First visit, we obviously had to set up our plots and stake our rows. We did 30 feet in length, and then the width depended on the planter. And my plot in particular was 12 rows. If somebody maybe had a 16-row planter, they would take it the full 16 rows. 24 planters. Most people, I think, only did half of that. And then also the first visit, you can see kind of here in these pictures, the emergence just starting to come up. So we did record the plant population right away. The second visit occurred just 7 days following that first visit. We went ahead and recounted the plant population again, ID'd any late emergers, and they ended up being probably at this stage a couple leaf stages behind already. So when we followed up with the third visit, another 7 days following the second visit, we once again recounted all those plants in those rows, labeled and ID'd any of the new emergents. And this is where we got into our skips. We recorded the number of skips. We called a skip anything that was had 12 inches in between plants, and then labeled the plants on each side of where that skip occurred. Our doubles were something that we got to get down and measure, and anything less than 2 inches was called a double. And then measured the plant spacing in the most and least variable rows. For our final visit, the fourth visit, this occurred during harvest time. We harvested the most and least variable rows and weighed them. The harvest followed up with what was the most and least variable. The second most and least variable rows were also harvested and weighed. We weighed doubles and skips separately, so that we could see if there was any compensation that occurred to the plants that were next to them. And we also weighed separately 3 normal ears, 3 late ears, 3 ears that were next to the late emergers, 3 doubles, and then 3 skips were all weighed separately to see how they came up at harvest time. This picture here, you'll see a few more pictures like this later on, but you can see where the skips were a double ear. Here a late emerger came up. This is from May 17th and then June 10th. You can see a lot of this year completely missed pollination. So like I said, you'll see some more of this field was from Foster County. We've got another one from Foster County and one from Wells County included. So with that, I'll hand it over to Joel. We'll talk a little bit about data.
Just taking a little bit of a look at some factors that affect corn yields, and this is probably nothing that's new to anybody, but obviously hybrid selection is very, very critical. Crop rotation versus continuous cropping of corn, uniform emergence, tillage systems for continuous crop and continuous corn, late versus early maturity groups, early versus late planting date population, uniform plant spacing, and then narrower twin rows versus 30-inch rows. And what we were looking at primarily here was a uniform emergence, which can have a 5 to a 9% effect on your total potential yield. And the other one we're looking at here was uniform plant spacing, which can have a 1 to a 2% effect on your potential yield. You don't think that's all that much, but if you add the two of them together, we're looking at 6 to 11%. So we're looking at, even on just a 100 bushel yield, we're still looking at 6 to potentially 10, 11, 12 bushels per acre. So those are the two agronomic practices that we were primarily working with here: uniform emergence and uniform plant spacing. A little bit more background on the plots that we worked with. As Lindsay pointed out, we had one in Wells County. It got planted extremely late, June 2nd. You all familiar with the spring we had? Bruce made reference to our spring conditions. Cold April, wet spring, late seeding. Just an indication here of the actual emergence that we received based on seeding rate. The field in Wells County at 36,000 seeding rate, an actual plant population of about 32,600 on July 3rd. So an actual change of just about less than 10% of what our actual seeding rate was. Foster County's field 1, planted May 17th, 30,000 seeds per acre planted, population established of about 28,500. Foster County field 2, planted May 24th, 35,000 seeds planted, and established plants of about 33,700. And then Eddy County field, the one that was actually harvested, planted May 14th, 30,000 seeds planted, 28,800 roughly an actual plant population established there. So, I don't think it's a big surprise that we have some decrease in actual plant population based on the number of seeds planted. Some more information just to give you a little bit more insight before we show you some data that we've collected so far. And as Tim pointed out, there's roughly 10, 11, 12 counties involved with this, and the information has not been summarized at this point yet. Hopefully something that will happen shortly after the Christmas break here, and we'll be able to see, look across the state at the 11, 12 different counties that participated and see where the data actually comes in. Then as Tim pointed out, we're doing the second year of the trial as well. This is a study that was done in combination of some studies done in Minnesota and also in Ontario. Effects of uneven emergence on corn yields. We have established a uniform standard here where we have a perfect emergence, all the plants emerging basically at the same time and so forth. And then there's some comparisons that this research showed. For example, one leaf stage delay on every other plant, you could expect about a 94% yield. Those plants that emerged normally got a little bit of a jump on those late emergers, and if you harvested just those plants, corn from those plants, you actually got an increased yield on those plants by themselves compared to the 100% base. But if you harvest those plants that were one leaf stage behind the standard or the normal, those plants produce, we lost about 20% yield just on that one leaf stage of those late emergers. The ones we want you to look at the most, because this kind of correlates with this work we've been doing, is this two-leaf stage. Because we had a lot of our late emergers were about 2 leaf stages behind. And if you looked at this study that was done previously, you get about roughly a 35% loss in yield of those late emerger plants. They just don't develop a cob. They're 1 week, 2 weeks behind, and we're just not going to produce a cob that's going to have the production potential that we would expect. When we did harvest, you see one of the first photo that Lindsay made reference to. That was field 1 in Foster County. This was field 2. A normal cob, normal spacing, come up. We have about 120, 125 days, growing degree days, GDUs, what we'd expect. There's a cob that emerged from, or came from a plant that emerged, approximately 2 weeks later. There's a cob that was selected right beside a late emerger, a double. In this particular case, this double is actually pretty good. Remember, a double is anything 2 plants together less than 2 inches apart. And then, of course, we've got our skip. And, remember the skip was a gap of more than 12 inches or more. And obviously, you expect that skip to be a pretty good ear because it didn't have the competition for nutrients and moisture and so forth that the normal spacing plants did. But realize, of course, we're missing at least, 12-inch skip, we're missing at least 1 plant. So yes, we had a bigger ear there, but remember we lost at least 1 ear because we're missing at least 1 plant due to the skip. This is from the Wells County field. Some of the same things here. Normal plant. This one's late emerger, just about 3 weeks late. And you can see some of the, Bruce made reference to some of these corn just not maturing or not developing those seeds, those full seeds all the way. Next to a late emerger, there's probably a little bit more what you expect out of a double. 2 plants within 2 inches of each other, a little more competition for nutrients and so forth, and moisture, especially as Bruce pointed out, we did get dry in July, August, September, and so forth. And then once again a skip, and once again you'd probably expect that skip to look pretty good because we got at least a 12-inch gap between plants, a little less competition there, good chance for better development. Taking a look at the weight of ears compared to normal ears, when we harvested, we selected out what we thought was a representative sample, what was normal, weighed those ears, and then we selected those late emergers, kept them separate, the skips, the doubles, and also the plants or the ears on plants beside the late emergers, and tried to get a measurement of what they weighed compared to what we considered our normal or our base weight. And you can see that in all cases, those late emergers weighed less than the normal ears. Even the plants right beside the late emergers also were a little bit lighter in weight. The skips were, if you look at the average, were about the same as the normal, which is a little bit surprising. We probably thought those skips would do a little bit better than that. And then the doubles, of course, you expect them to be smaller in size as well, therefore producing less bushels. If you look at the averages, the late emergers as a whole in the three fields that we had looked at in Foster and Wells, were about 39% off on weight compared to what we determined was a normal weight of an ear in that particular field. The next ones, the plants or the ears selected from the plants next to the late emergers, about 13% off. The skips about normal, and then of course the doubles were off about 10-11% as well. So what have we determined so far? Probably not a whole lot yet. We've just done this 1 year, and that's just the plots in the Foster, Eddy, and Wells County area. We don't have the information or the data from the other counties at this time, but as I said, we hope to see that information in the next few months. And then we're running a trial again next year, so we've got at least 2 years worth of data. Probably not going to find things that you're probably not familiar with. You need to go out there and start out with a good, high-quality hybrid seed. Work with your soil conditions. Obviously, this year is a little tough to do that. Make sure the soil is not too wet so we can avoid some compaction problems and so forth. Make sure our seeding equipment is in top condition. Replacing worn out parts and pieces and so forth so we get optimum operation out of our seeding equipment. And if at all possible, maybe back off and slow down a little bit when we're actually doing the seeding process. Now, obviously, if you're out there at the end of May, the first week of June, it's awfully hard to convince yourself you need to slow down, like we did this last year. I mean, you realize you got to get it in the ground. You're not quite as concerned about speed and so forth. So, probably, not a lot of big revelations at this point. But like I said, we're going to run the study again, and then we'll get the statewide data from the 2 years and see if we find any trends that might be similar or different from what the other states have done when they've done these type of emergence trial research work on corn emergence. Any questions you may have? The four of us will try to answer those.
That double, did the second plant abort then? Or did you have 2 cobs?
No, there's 2 separate plants. When we call it a double, it was 2 separate plants within 2 inches.
2 plants side by side, right?
Yes.
Okay, the cob was shorter, but you should have 2 cobs if there was 2 plants, right?
Right, yeah, and that was an indication of just one of those cobs.
Yeah, what was the other one like?
Basically the same, yeah.
So there's actually a longer cob than that. You add those 2 together, that makes it better.
Oh, okay, yeah, I see what you're saying. Yeah, you're right, yeah. Add the 2 together, you have one really good cob.
Yeah.
Oh, I see what you're saying, yeah, that's true.
But you should have 2 normal cops
Yeah.
Yeah.
instead of 1 good cop.
Right.
So like the population should have been 45, 50,000.
Yeah. Yeah, we didn't have a big range. I think we were 30,000 to 36,000. So in those 4 fields that we worked with, we didn't have a huge range, but we had a substantial range. We didn't have any 40, 42, 45,000 seeded population. We did have some variation.
Hey Joel, did you check the moisture content of just like the late emerged ears? See if they were higher?
Separately?
Yeah.
We did not. We did do moisture checks, but not separately. That's a good point.
Oh, with test weights?
I think we took a representative sample. I don't believe we took individual.
4 rows where we looked at the different variability, we took test weights on rolls.
On rolls we did, but not individual cob. That's good. That'd be something we could look at. Yeah. Good point. It'd be something that'd be interesting to see if there's a variation there on those late emerges as far as maturity and dry down and test weight and so forth. Yeah.
Because if they were a lot higher in moisture, your yield was actually influenced more by the water content then.
Right. Right.
Did you look at seed depth variability between the early and late emergence?
All of ours were 2 inches. All of our plots that we worked with, so we didn't have any variation there in seed depth. But yeah, that's a question that's come up before, and all these were at 2 inches. Good question. You're right. We didn't have any variation there. All of our producers that we worked with in these 3 counties were at 2-inch depth.
What type of planters did you use?
We had 3. We had a John Deere, we had a Case IH, and we had a what was the other one? Kinsey. We had 3 different planters between Foster and Eddy, and what did you have? Or Foster and Wells. You had a
John Deere.
You had a John Deere and Eddy as well.
My other plot that I didn't take the harvest was a Case IH there.
So you saw this variability in every trial. We had 3 different planters.
Right. Right.
Percentage-wise in the field, one planter different versus the other?
At this point, no, not at this point. But that's just our 3 fields, or 3.
But you're seeing a very, I mean, all 3 planters are doing the same thing.
At this point.
Yeah.
And I don't think any of that's been tabulated yet. I mean, they'll pull that back in and pull that data into it. We've done our local data, but we haven't drawn the conclusions between planners and things yet.
And that's another reason to do at least another year's worth too, so we can get enough data to see, okay, is there an actual difference between planters? Now, unfortunately, we didn't have any variation in our area on seeding depth, but I'm not sure about the other counties. We haven't seen that data yet. But very, very important aspect of the project.
How many days per leaf? Because you were saying 1 leaf or 2 leaf difference. How many days is it to have a leaf difference?
Greg?
On the data we generated, it was about 10 days average amongst the different fields that we were looking at.
10 days per leaf.
No, 10 days. It was more like 10 days for 2 leaves. But as an average, we went out there and our first plant counts, we measured those, and then subsequent times we were out and we measured again. We didn't. When we noticed the late emergers, it wasn't, of course, that day. It might have been 2 days before, 3 days before, and so that's when there's a little variability in here. But if you remember the slide that was showing, on average it was, there were 2 leaves behind, it was about 10 days.